All right, let's just dive right into this explainer. Welcome, everyone. Today, we've got a truly fascinating journey ahead of us as we pop the hood on artificial intelligence. You know, we hear about AI literally everywhere right now, in the news, at the office, in our daily lives, but there is a massive, massive gap between what we kind of assume AI is doing and what is actually happening scientifically. So, our goal today? We're going to strip away the magic, clear up all the confusion, and give you a rock-solid, high-level understanding of the architecture that's actually driving this whole technological revolution.
It's the ultimate question, isn't it? Does AI actually think? When you type a prompt into a chatbot and it spits back this beautifully structured essay or maybe a really empathetic-sounding reply, it is incredibly easy to fall into the trap of believing there's a conscious, thinking brain on the other side of that screen. We naturally assume it's interacting with us the same way a human would, but I want to challenge that illusion right out of the gate. The intelligence we're all marveling at is, quite literally, artificial. There is absolutely no cognitive thought process happening, zero. So if it isn't thinking, what in the world is it actually doing?
To answer that, we need to introduce a really core concept here. Instead of calling it a thinking machine, it is so much more accurate to define AI as an extant knowledge generator. Now, extant simply means something that currently exists. This machine is not creating entirely new thoughts out of thin air. Instead, it's performing this incredibly complex probability distribution analysis. Think about it. It has ingested billions of data points, text, images, human interactions, the whole shebang. And it's learned the mathematical patterns buried inside that data. So when you ask it a question, it isn't pondering an answer, it is mathematically calculating the highest probability of what the next word or the next pixel should be, based purely on the historical human data it was trained on.
Okay, Section 1, Mapping Probability in Clusters, Sorting the World's Data.
Let's break this down with a really relatable analogy. Imagine you hand the AI this massive, chaotic pile of words. Because it doesn't actually know what a cat is in the real physical world, it just looks at the text data and notices, hey, the word cat frequently shows up near words like house, pet, and dog. So mathematically, it just groups them together in a domestic cluster. On the flip side, it notices words like lion and tiger are usually hanging out near words like jungle and wild. It builds this giant internal dictionary, not by defining what words mean, but by organizing them by statistical similarity. It's essentially playing the world's largest game of word association. If you ask it a question about a cat, it instantly zooms over to that domestic cluster to grab the most probable response. Now, checking out how this mathematical vector space is laid out completely proves that animal analogy. Notice how words are quite literally floating in specific semantic clusters. Apple, banana, and orange are physically grouped together as fruits. King, queen, and prince are clustered as royalty. When an AI gets your prompt, it translates your human words into these high-dimensional numbers, navigates this vast geometric space, and plots a trajectory to fetch the exact data points that align with your query. It's not biology, folks. It's geometry.
To really hammer this home, let's look at this exact quote from our source material detailing the architecture. The system places all the data into a probability distribution, plots a graph, and places words into what we call clusters. That right there is the fundamental architecture of generative artificial intelligence. It behaves almost as if it has thousands of invisible hands, rapidly searching through these mathematical clusters to pick out exactly what you're looking for. And honestly, that speed and precision is exactly why it feels so incredibly intelligent to us.
Moving on to Section 2, One Engine, Many Vehicle Brands, the generative architecture. So here is the crucial takeaway. I want you to think of generative AI exactly like the automotive industry. A Toyota Camry and a Mercedes-Benz look totally different on the outside, right? They've got different features, different branding, different dashboards, but under the hood, they both run on the fundamental principles of the internal combustion engine. In the AI world, our engine is the transformer architecture. That's the pre-trained deep learning framework that uses self-attention to process data. The vehicles, well, those are the brand names you already know: ChatGPT, Gemini, Grok, and Claude. They are all running on the exact same underlying mathematical mechanism.
Just like different car manufacturers, different tech giants have built their own vehicles around this transformer engine. OpenAI gave us ChatGPT, and because they trademarked that business name, Google had to build their own version and call it Gemini. Elon Musk's XAI company, they built Grok. But remember, it's all fundamentally the same generative pre-trained transformer technology. The real differences are mostly in the specific data they were trained on, how they fine-tune their interfaces, and essentially the size of the engine. Think of it like the difference between a zippy little sedan's engine and a massive 18-wheeler's engine that's designed to haul much heavier computational loads.
Section 3. Specialized tools for specific jobs. Fine-tuning the engine.
Now, general models are fantastic, but the data you feed the engine completely dictates its expertise. Claude, for instance, was heavily trained on data relevant to researchers. That makes it absolutely exceptional at literature reviews, sourcing materials, and generating complex code via GitHub integrations. Perplexity? That one is hyper-focused on real-time web research. On the visual side, we've got Midjourney and DALL-E for image generation. And then we have these highly personalized, super niche models like Synthesis, which is built exclusively for generating outputs based on organic chemistry reactions.
And this brilliantly illustrates just how insanely specialized these tools can get. We aren't just talking about an AI guessing the next word in a sentence here. This is the synthesis model outputting a highly complex transition state energy graph specifically generated for chemistry labs. By restricting the AI's training data to very specific domains, like organic chemistry, we get a tool that isn't trying to be everything to everyone. Instead, it becomes this precise, domain-specific assistant predicting chemical pathways using the exact same probability distribution math that ChatGPT uses to write an email.
Now for the visual tools like DALL-E and Midjourney, the application of this math is slightly different. They use a fascinating process called diffusion. Think of diffusion kind of like a master sculptor working with a block of marble. The AI starts with a canvas of complete static, just random pixelated noise. Then, based on your text prompt, it iteratively chips away at that noise, pixel by pixel, reversing the visual decay until a sharp, high-resolution image emerges. What's absolutely wild is that it performs this mathematical sculpting across millions of pixels in just seconds. It doesn't actually know what a sunset looks like. It just mathematically understands the probability of where light and dark pixels should sit relative to the word sunset based on its training data.
Which brings us to our final part, Section 4. The human-AI synergy, steering the machine. If you take away just one single thing for your day-to-day application, let it be this. AI is a high-speed engine, but prompt engineering is the steering wheel. Remember those data clusters we were talking about? If you just toss the AI a super vague input, it's going to aimlessly wander the most general, average clusters of its database, and you are going to get a generic average output. Because it relies completely on statistics, you have to precisely guide it. By providing rich context, specific constraints, and clear personas in your prompts, you literally force steer the model into the exact high-quality data pockets you need.
And honestly, that brings us to a reality that is completely reshaping the modern workforce. Artificial intelligence will not replace humans, but humans using AI will replace those who do not. The people who are going to thrive aren't the ones who fear the machine, nor are they the ones who blindly trust it as some all-knowing brain. The real winners will be the focused learners who understand it for exactly what it is, a powerful probabilistic tool. Mastering that steering wheel, learning to expertly navigate those vector spaces and data clusters through really skilled prompting, that is the ultimate competitive advantage of our time.
So, we've kind of pulled back the curtain, right? You now know that AI isn't a thinking entity. It's a brilliant mathematical mirror reflecting our own human data back at us. You know about the underlying engine, the probability clusters, and the specialized vehicles built on top. So I want to leave you with this final provocative thought. Now that you know it doesn't actually think, how are you going to steer it? Thanks so much for joining me in this explainer. Keep exploring and go start putting these concepts into practice.